All right, so now we've learned a bit about the rules of scientific notation. We're going to learn how to take a regular number. Here's two numbers that we've seen these types of numbers before, and we're going to change them into scientific notation. So the first thing we need to think about is the format that our scientific notation needs to follow. So remember, there's a box here, and then we have times 10 to the power of something. We'll leave this blank right now, okay? Maybe I'll just put a big circle here. We're going to fill it in with a number. So the first rule says that this number that we choose to go in here needs to be between 1 and 10. The way we do that in this case is we take the whole thing that we've got here, the whole number, and we look for a place where we can put the decimal so that we have a number between 1 and 10. If we put it between the 5 and the 6, we end up with 5.6, and that is a number between 1 and 10, and that's the number we're going to put in here. So 5.6 goes here, and then we do times 10 to the power of blank. We don't know yet. So originally, my decimal point is at the end of this number. I moved the decimal point to be between the 5 and the 6, so I could create a number between 1 and 10, 5.6. I now need to count how many spaces I moved the decimal to the left. 1, 2, 3, 4, 5, 6. So each space counts as a power of 10. So above here, I'm going to put 6 to represent 1, 2, 3, 4, 5, 6 spaces that I moved to the left. Okay, so that's the first example. 5,600,000 can be written as 5.6 times 10 to the power of 6. In this example, same process, we're going to find a number that can fit between 1 and 10 that goes in this box here. Okay, you don't need to draw this box every time. I'm just doing it to help you. Okay, times 10 to the power of some unknown thing. Okay, so the best location to put the decimal point is right here between the 2 and the other 2. And I need to count now how many times I move the decimal to the right. So I count 1, 2, 3, 4, 5, 6 spaces to the right. I'm trying to draw an arrow here, but it's not really working. Okay, so because I moved the decimal, sorry, I forgot to put this in. So here's 2.2. Okay, and when I made it 2.2, the decimal point got moved to this location. So I need to count how many spaces from the original decimal point up here to the new location. So in this case, it was 6. But because I have a very small number, 0.00000, that's a very small number, this now becomes negative. Okay, so instead of writing +6, I've got to write -6. And my circle is so small, I'm going to erase it quickly here. Okay, so instead of writing +6, I'm writing 10 to the power of -6. So we can have a negative power here. It just represents a very small decimal number. All right, so that's how you move from a regular number into scientific notation. These are big numbers, 5,600,000, so it has a positive power. And this is a very small number, 0.000022, has a negative power. All right, so those are the important things to remember about this.